It seems like we've introduced a lot of properties all at once. But if we think hard about it, they all reflect the same basic property of an atom. That is, how well does that atom attract electrons? Radius and ionization energy reflect how well an atom attracts its own electrons. If it's better at it, it will more strongly pull in the valence electrons, resulting in a smaller atom, and those outer electrons will be harder to remove or will take more energy to remove. Electron affinity and electronegativity are measures of attracting electrons from elsewhere, whether it be a free electron or electrons in a covalent bond. So, for all these properties, they're all related to what those outer electrons actually feel. It may be helpful to think about a continuum. At one end, there are atoms that are poor at attracting electrons. At the other end, there are atoms that are good at attracting electrons. Let's think about atoms at the right-hand end of the continuum, those that are good at attracting electrons. How is that reflected in these atomic properties? First, what about the size or radius of the atom? Would it be large or small? Well, if you're good at attracting electrons, you're going to pull them in closer to the center, so you will have a small radius. Next, will you have a large or small ionization energy? If you're good at attracting electrons, it will be hard for someone else to remove them. It will take a lot of energy to do so. Therefore, you will have a large ionization energy. What about electron affinity? If you are good at attracting your own electrons, you should be good at attracting electrons from elsewhere. You should have a large affinity for electrons. More technically, the better you are at attracting electrons from elsewhere, the larger the energy change that electron experiences when it binds to you. Next, electronegativity. Will it be large or small? If you're good at attracting electrons from elsewhere, you will be good at attracting them in a covalent bond, so you will have a large electronegativity. Now, will those electrons involved in these properties feel a large or a small positive charge from the nucleus? Coulomb's law tells us that when considering a negative electron and a positive nucleus, larger charges will have a stronger force of attraction. So if you're good at attracting electrons, those electrons will feel a larger positive charge from the nucleus. Finally, what about the energy of those valence electrons that are measured by these properties? Again, we appeal to Coulomb's law. Since those valence electrons feel a large positive charge, the energy will be more negative, which we defined as lower energy. If we think about trends on the periodic table, atomic radii generally get smaller as you go towards the upper right of the table. Those are the atoms that are good at attracting electrons, so they also have large ionization energies, large electron affinities, and large electronegativities. Their valence electrons feel more positive charge and are closer to the nucleus, so they are at lower energy. As one goes toward the bottom left of the table, we find atoms that are larger. They are poor at attracting electrons, so they also have small ionization energies, small electron affinities, and small electronegativities. Their valence electrons feel less positive charge and are farther from the nucleus, so they are at higher energy.